the first official day of hybrid learning. Just as I promised, I am going to start with our first official joke of the day. This is a really, really big deal here. I know you are all super anxious and excited to hear who the first lucky winner is. Our first lucky winner is Mr. Tanner Filbrin, coming in hot with a joke of, how do you tell if a vampire is sick? Well, of course, if it is coughing. Well done, Mr. Filbrin. So today, I want to go ahead and tell you what it is we're going to be doing here on this fine Monday. So we are going to be talking about sound. So far last week, we got done talking about waves and how they travel in transverse and longitudinal waves. If you can remember back then, last week, I told you that longitudinal waves are examples of sound waves. So we are just going to focus on those longitudinal waves this week in terms of sound. Of course, you have to use your ears for sound, so we are going to be talking about the parts of the ear as well. So in this Google slide, I'm going to walk you through what it is we're going to be doing. I'm going to go over your warm-up with you to make sure you get 100% on that, and then we will rock and roll. So here we go. Today's to-dos on Monday, November 9th. You're going to first start with your warm-up, just like what we do every other day in class. You are then going to be watching me complete the launch lab. You are going to be answering questions on that as I complete it. We will do that later in the video here. And that is about how is sound produced. And lastly, I will give you some time today to work on your science notebook. So with that being said, let's go over your warm-up for today. Your question today is, what is a sound wave? That can be found on page 111. You can either go to your online textbook right now, just like I had you do on Thursday of last week. I had you create your science folder, and hopefully you have that in there. So you can just click on that online textbook. Today, I'm being extra generous because I'm going to just put it on the screen for you right now. So the question is, what is a sound? Well, let's take a look at it right here. We have to look at the first paragraph of this lesson on page 111. So the first paragraph says, have you ever walked down a busy street and noticed all the sounds? You might hear many sounds every day, such as the music from an MP3 player or your phone or iPod, as shown in figure 1 there on the right-hand side. All sounds have one thing in common. The sounds travel from one place to another as sound waves. Here's your answer right here with the yellow word. It's one of your vocab words this week, which you do not have very many of. Your answer for your warm-up today on Monday is a sound wave is a longitudinal wave that can travel only through matter. Remember, longitudinal waves can only travel through matter because it's a form of a mechanical wave, right? The other form of mechanical wave is a transverse wave. So transverse mechanical waves are the only ones that travel, they have to travel through matter. The other wave that can travel through matter and empty space is the electromagnetic wave, which is not a sound wave. That would be like an X-ray. Right? So again, just to reiterify the point and the answer for today, a sound wave is a longitudinal wave that can travel only through matter. Make sure you post that on Google Classroom in order to receive your 5 points. The rules aren't changing there. Still going to be 5 points for every single day. You can earn up to 20 points every single week in order to get your 20 points. Now, this is even easier because I'm going over the warm-up with you. I don't normally do that, so there's really no excuse to not get 100% on your warm-ups. Hopefully you take this opportunity to boost your grade. Now, what is it we're doing next? We are going to be completing this launch lab. Okay, this is what I'm going to be completing for you. You're going to be watching this here next. But what I have to do is teleport to school, and I will show you how to complete this lab. Hello, now that I am back here at the school, I told you I was going to teleport. Let's go ahead and complete this lab. So the lab that you are going to be completing is rather simple. All you are going to do is watch me take this ruler, okay, normal ruler, and we're going to put it here on the edge of the table. Okay, the further out that I pull the ruler, the more ruler is off the table, of course. So if I go ahead and flick the ruler, okay, you will notice a sound. And let me pull you closer here so you can hear this. Okay, so the further out I pull it, you're going to notice a much longer wavelength. If I pull it back a little further, you're going to hear a little higher pitch. The least far, you're going to hear the lowest pitch. Let me model that again for you. Furthest out, and you can physically see the waves here. Shorter and shortest. Okay, now, why is that? Same exact idea we're learning about sound waves, which is right behind me here. Okay, you can see right here is when we had the least amount of ruler hanging off of the table, right? It's going to be the shortest wavelength. Okay, remember, these are longitudinal waves. Now, if you want to relate this back to when we did the tuning forks, okay, whenever it's the least amount off the table, it's basically like having the short tuning forks. Okay, now opposite of that over here is when we had the most amount of the ruler off of the table, right? So it has the slowest vibrations, therefore it's going to have the longest wavelength. And remember, the wavelength, what is that? How is that measured? Is the distance from right here, the crest or the trough, to the trough. Okay, you can do either or there. Same exact idea over here, and you've modeled this already before, so this should not be a surprise. It is from this trough to this trough. You can see that that's a much shorter distance because we have much more rapid or fast vibrations. Now, you need to now move on and answer the questions. You're not really missing out on a ton there. It's not like I made something explode or anything cool like that. But I did want to model that for you just to see what's going on. How can I make a slow vibration, and what does that wave look like? How can I make a short or rapid vibration, and what does that make that wave look like? And how does that travel to your ear? Now, you're going to answer the following questions, and I'm going to cheat because I have it up on the screen here. It says, how did the ruler's vibration rate and the sound rate change as the length of the ruler over the side of the table decreased? Well, just like I just got done explaining to you, okay, the smaller amount of the ruler that is off the table, the more rapid the vibration, okay, and the closer the wavelengths. So that's what you need to say, something along those lines there. Number two, the key concept of this lab is, were the sound and the ruler's vibration rate related? Were the sound and the ruler's vibration rate related? Hopefully you could already answer that question. Of course, because we're changing the wavelength, as you can see here, as we've already talked about, that's going to hit your eardrum and it's going to process as a much different pitch, which is one of your vocab words for this week, right? So this is going to be a much lower pitch, which is when the ruler was the furthest off the table. This is going to be a much higher pitch, which is when the least amount of the ruler was off of the table. Okay, those are your two answers. Okay, hopefully those are pretty basic answers, pretty basic lab here. Okay, it's not groundbreaking or anything like that, but understand the difference between these two different kinds of waves. Next, I'm going to explain to you what you need to complete for the second part of. Okay, so last but certainly not least, let's take a look at what you need to complete for this second portion in order to earn your 50 out of 50. The first part of that lab that I just got done explaining was pretty simple. So let's look at the directions here at the top. So in the puzzle below, each number will correspond to one letter of the alphabet. For example, 11 equals E. Shaded letters will not be used, so you don't need to worry about the shaded letters. Crack the code by using the clues for hints. After you read the clues and fill in the blanks, complete the chart with the number that corresponds to each letter you have used. These are going to be vocab words. Okay, I understand you only have 3 vocab words this week, so you may use your online textbook in order to figure these 4 out. Okay, 3 of them are going to be your vocab words. Okay, it's going to be relatively simple here. You don't really have to use much of the code if you look at the definition, and then you go ahead and plug that in for the letters of the word. Hopefully this first one, since it's one of your only 3 vocab words, is really simple. A reflected sound wave, which is what we're about to talk about here in the next segment of this video. So if you want to skip to that part and come back to complete this, I'm totally okay with that. But hopefully this makes sense. Again, mostly vocab words, but you may use your textbook to look up the definition to plug in the letters here. All right. So what I'm looking for is 1 and 2, as well as 1 through 4 to earn your 50 out of 50 for this lab. Let me go ahead and teleport back to my house, and let's finish off our lesson for today. And welcome back. Now that you have completed your lab, make sure that you submit that. We are going to now move on to our next step, which is the science notebook. Now, just like normal, you are going to turn this in no later than Friday. But I think you should have plenty of time, since you're going to be on your Chromebook all day, every day, working on these materials. I think you should be able to turn it in before then. But I'm not going to force you to do that, because I am such a nice guy. Now, here are your vocab words. All right, you only have 3 of them. That is it. I'm not going to make you do any more or any less. Normally you've had 10, 12. I think 12 is probably the most you've had. But 3 words is all I'm asking you to do, which is all that is in this lesson. Okay, so we have a sound wave, we have pitch, and we have, let me move my head, we have echo. Okay, sound wave, pitch, and echo. Now let's go through each of these and talk about them. So sound wave, which is what you should have answered for your warm-up today, is a longitudinal wave that can travel only through matter. I know I've already said this once, but it's okay for you to hear me say it again. A longitudinal wave is a form of a mechanical wave, meaning that it has to travel through matter. Okay, I'll say that one more time. A longitudinal wave has to travel through matter. So this picture right here where my cursor is similar to what you modeled with the Slinky last week. Okay, I know it does not look exactly like that, because that would be a pretty funky looking Slinky, but this is like a sound wave. If you started screaming at the top of your lungs and then we're silent, yell it again and then we're silent, yell it again and then we're silent, this is what it would look like. Okay, this right here has the compressions, which is where they're all really close together, and the rarefactions, which is where they're more spread apart. Okay, hopefully, again, now that we've gone over this from last week, you know what an amplitude is, you know what a wavelength is. So for example, for the resting position, which would be a straight dotted line, imaginary line right here in the middle, up to the top, which you should know at the top of your brain, that is the crest, or the bottom, that would be the trough, right? And then you should know that the wavelength would be from crest or trough to trough. Okay, so that is a sound wave. Okay, again, you are going to be doing this on a Jamboard. I'm going to have this uploaded for you, a link to that if you forgot to put that in your bookmarks tab for science. But you are going to be completing this virtually. You will not be able to turn this in to me in your normal science notebook. I wish you could. I wish I could get to see you every single day, but that's just not the case this week. So please make sure that you upload that to the post I have also put under today's topic. Okay, it will be science notebook sound. Okay, science notebook sound. Don't mind my dog here trying to be a part of the video. Now, my next word is pitch, which is the perception of how high or low a sound seems. So if I were to make my voice go very, very high, I'm not going to do that because you would make fun of me, would be a very, very high pitch. If we use an example of a lab that we've already completed, think about the tuning forks. The tuning forks, we have the short one was a very, very high pitch. Probably hurt your ears if you were to put that up to your ear. Versus the very, very long tuning forks, if you were to hit that on the table, then that would be a very low pitch. Okay, that is pitch. You can use the pictures that I have here on the screen. You do not have to do the exact pictures This week, I'll be even more generous. If you want to upload pictures from Google, that's fine as long as they are appropriate and as long as they go along with the word. But I want to challenge you. I want you to actually physically draw the pictures. Okay, you do not have to, but I would like for you to. Last but not least, your last word is, if I can move my head here, echo, which is a reflected sound wave. So if you went to the mountains, if you went down the hallway right now and you screamed at the top of your lungs, please don't do that, because I know you will tell Mr. Kimberly that I told you to do that and get me in trouble. But if you did, it would echo down the hallway because it is a reflected sound wave. Those sound waves bounce off of the wall and they come back at you. You can hear yourself say it more than once. I'm sure many of you have experienced this before. If not, a hallway would work well. If you were in the mountains and tried to do it, it would bounce off of the mountains. That would work well. Though that would be an example of an echo. Again, you can use this example of the picture that I have drawn. You do not have to, but it's just an idea and something to think about. Okay, those are your 3 words. I expect you to put that on one Jamboard. Okay, do not upload 3 different Jamboards. And just like I mentioned to you last week, do not hit the blue share button. Okay, you need to download it as a PDF and then upload it to the post that you see under today's topic, which is Science Notebook Sound. Okay, that is all you have to do for this week to earn 25 points. I think doing 3 vocab words for 25 points is a pretty easy task. Next, what you need to do is make sure that you upload it and you are done for today.